So this problem 106 is actually going back a little bit earlier into the unit, back to impulse, but I wanted to do an impulse problem in multiple dimensions to sort of show you how to do that a little bit, because you have some problems, or at least one problem dealing with that. So, whoops. So you might have, um, you're probably watching this video last, just because of the order, but it's technically an earlier-ish video. So problem 106, the reason why is because it's in the additional problems. I couldn't really find a good one in the regular problems under this section, so yeah. Alright, so you get a ball that hits a wall, and the mass of the ball is 0.15 kilograms. The velocity initial of the ball, right before it hits the wall, it has a velocity in the x direction of 5 meters per second, in the y direction of 6.5 meters per second. And in the z direction, a speed of 4 meters per second. Then after the rebound, after the bounce, it has a final velocity in the x direction of 2 meters per second. So it doesn't really bounce back. You can most likely the k direction is into the wall. The x direction is like along the wall horizontally. Maybe I can draw that. So like you got a room here, right? Here's the corner of the room. And you might have another wall here. Probably should have done it the other way. But anyway, so here's your room, right? So we could say that the x direction is maybe, this is kind of unorthodox, but whatever, maybe that way. The y direction is that way, and the z direction is that way. So the ball will come in, I guess, sort of like this. So it starts on the back side of the room, and then goes up and over, hits the wall maybe in the middle-ish, bounces, keeps going up because both the x and the y velocity are positive finally. So it bounces, but it bounces back and comes to the front of the room. Probably can't see that well. Picture something starting at a ball like starting at the far end of the room, sort of in the middle of the room, going towards this wall and towards us, hits the middle of the wall, continues bouncing up and towards the front of the room here. Front, back is back here. So it keeps going up and towards us, but it comes back out towards the middle of the room this way. So in the z direction it changes direction. It goes in and then out. Whereas in the x direction it keeps going to the front always. In the y direction it keeps going up, at least right after. Maybe if gravity plays a role it'll bring it back down eventually, but anyway. So that's what it doesn't state this in the problem, but that's what this might represent. This might give you a good picture of it. So anyway, 3.5 in the j direction. Whoops. Oh, caught myself. I almost hit undo. That's bad. That's bad. Minus 3.2 meters per second in the k direction. Yeah. Alright, part A. um, delta P. So literally I drew A, right? Looking at the screen. Then I went and looked down at my paper while drawing the circle, and somehow it got really big. Delta P, change in momentum, impulse is m times v final minus v initial in general. So let's do delta Px. By the way, your book, the answer in your book, it doesn't find the magnitude of these three dimensions. It just keeps them separate. I'm going to do it just for the fun of it. So the mass is out, well, okay, delta P y, delta P z. The mass is the same always, 0.15, 0.15, 0.15. V final on the x, so 2 minus 5, 2 minus 5, 3.5 minus 6.5, 3.5 minus 6.5 in the y direction, these two. Negative 3.2 minus 4 wow, equals, and this equals negative 0.45 kilogram meter per second in the I direction. This equals negative 0.45, the same thing. Kilogram meter per second in the J direction. And this equals negative 1.08 kilogram meter per second in the K direction. So again, the book leaves it just like this, but what you could do is you can Pythagorize these. Delta P total is the square root of delta Px plus squared plus delta Py squared plus delta Pz squared, so negative 0.45 squared plus negative 0.45 squared plus negative 1.08 squared, and that equals 1.254 kilogram meter per second at some angle, which I won't bother doing. Part B, well, part A wants the change in momentum. We got that. Part B wants the impulse. Hey, impulse is a change in momentum. Same answer. Or same answer. Part C, J of the wall has to equal J of the ball, but the ball is pushed back this way and up and over. The wall is pushing the opposite direction, Newton's third law. So actually we need a negative here. So you could change the signs of these, or you could, once you find this angle, do like, well, a little tricky in 3 dimensions. If it was 2 dimensions, you could just do 180 in the opposite direction, but essentially the impulse is opposite. And that's it. Alright. Chapter 10 is next for you.